Hello everyone, and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 13th problem from the Special Maths Contest 2024 first round. And it says, let Q of x be a polynomial in x such that for some real constants a, b, c, d, we have that x squared plus ax plus b times q of x equals to x to the power 5 plus cx plus d. Then q of a is equals to what? Okay, so let's look at this problem. So first things first, if we just plugged in a, would have a squared plus ax plus b times q of x. We have this equals to x to the power of 5 plus cx plus d. Okay, so we plugged in a, would have a squared plus a squared again plus b times q of a equal to a to the power of 5 plus CA plus D. So basically we have Q of A is equal to a to the power of 5 plus CA plus D. Okay. All over. So basically a squared plus a squared, that's 2a squared plus B. Okay. And we don't have this in the options, but it's possible that something in this, something among these options is equivalent to this based on the structure of the problem. So let's explore further. Now, we know that Q of x is a polynomial, but what degree is this polynomial? Okay, so we have a quadratic being multiplied to this polynomial to give a polynomial of the fifth power. So what does that give us? That gives us that Q of x is going to be a polynomial of degree 3. So the degree of Q of x is going to be equal to 3. So we can say, and also we have that okay, so let's just put it this way. So we can say x squared plus ax plus b. Okay, so now we could have something like ex cubed. But I'm going to skip this because the fifth power on the right hand side is 1. So basically, we can quickly infer that the uh the the coefficient of x cubed in q of x is going to be 1. So this is x cubed plus ex squared plus fx plus g. This is equals to x to the power of 5 plus cx plus d. Okay, so let's do some analysis. Okay, so let's look for the coefficient of x to the power of 4. Okay, so x to the power of 4, we can combine. So from the first bracket, we can take the second power of x and multiply it to the second power of x in the second bracket, or we can take from the first bracket x to the power of 1 and then multiply it by x to the power of 3 in the second bracket. So basically the coefficient of x to the power of 4 is going to look something like this. So basically we have that x squared times ex. Okay, so that's going to be e. Then we can have uh, ax times x cubed. Okay, that's going to be a. Okay, so this the coefficient. I'll just put it here. Okay, let's look at, and we know that it's going to be equal to 0. So let's just have this. So basically, we can just put e is equals to minus a. And let's look at x cubed. X cubed, we can do it in so many ways. So we can have the coefficient of 2 and 1 here. So the coefficient of the second power of x in the first bracket and multiply by the first part by x to the power of 1 in the second bracket. Okay, so I'll just use that to denote that. Okay, can be 1, 2, and it can be 0, 3. Okay, so we can't have 3, 0 because the first bracket does not have x to the power of 3 anywhere. Okay, so this is going to be 2, 1. going to be f. Okay. 1, 2. So ax times ex squared. So that's going to be ae. And then 0, 3 is going to be b. Okay. So this is equal to 0 again because we know that the quotient of x cubed on the right-hand side is 0. Okay, so we can substitute. We know that e is equals to minus a. Okay, so we can put it here. And then we just get uh, f minus a squared plus b equals to 0. So this implies that f is equals to a squared minus b. Okay, and let's look at x squared. So x squared, we can have 2, 0, can have 1, 1, we can have 2, 2. So I'm just counting systematically so that, sorry, we can have 0, 2. Counting systematically so that we can see that we're not skipping any possibility. Okay. So x squared, so 2, 0. So x squared from the first bracket multiplied by g. Okay, so that is just g. 1, 1, that is ax times fx. So af. And then 0, 2. So that is b times ex squared. That is be. Okay. So we know that this is 0 again. Okay. So this implies that, so we can substitute. So for instance, we know that e is minus a. So we have g plus f is going to be, okay, f is this. So we have a into a squared minus b. And then we know that e is minus a, so plus b into minus a is equals to 0. So I'll just skip and we can get that g is going to be equal to 2ab minus a cubed. Okay. Now what else can we get? So let's see. Okay. So in this expression for Q of A, we have C. Okay. And so I think, yeah, to get C, we have to consider the coefficient of X. Okay, so let's look at the coefficient of X. We can either take the constant and multiply it by X in the second bracket. So let me do it in, let me count in the way I've been counting. Okay. So 1, 0 or 0, 1. Okay. So 1, 0 is going to be B times Fx. So that is going to be BF. Okay. And then 0, 1 is going to be, or that 1, 0 is going to be A times, so sorry, A times G. And then 0, 1 is going to be B times F. Okay. So this is the coefficient of X. And we know it's equals to C. Okay, so let's see what we can get. And then let's look at the coefficient of the constant coefficient. So the coefficient of x to the power of 0. That's just going to be b times g, basically. So our bg is equals to d. Okay. And we have bg equals to d. Okay. So let's leave it leave it at this. Mhm. Okay, so let's simplify C. So we have C is going to be equal to, so A, so remember that G is 2AB minus A cube. So basically I'm working on this to get this. So it's going to be 2AB minus A cube, okay? And so plus BF, so B into, so F is A squared minus B, okay? So we can simplify this further. So C is going to be equal to, let's simplify this. 2A squared B minus A to the power of 4 plus A squared B minus B squared. So we have C is equals to 2, so 3A squared B minus A to the power of 4 minus B squared. Okay, so just put it in a box to show that it's important. And then we have D is equals to BG, which is equals to B into 2AB minus A cubed. So we have D is equal to 2AB squared minus A cubed B. Okay, let's go back to our expression and see if we can simplify it. So let me scroll down a bit. Yeah. So we have Q of A is equal to A to the power of 5 plus CA plus D all over 2A squared plus B. So let's substitute. So this A to the power of 5 plus, so C is going to be 3A squared B minus A to the power of 4 minus B squared. So this times A plus, so D is 2AB squared minus A cube B. Okay, so this is A cube divided by 2A squared plus B. Okay, so this is going to be equal to, so A to the power of 5 plus 3A cubed B minus A to the power of 5 minus AB squared plus 2AB squared minus A cubed B. Okay, so let's all divided by 2A squared plus B. Okay, so let me scroll down a bit again. So we have A to the power of 5 minus A to the power of 5. This goes out. Okay, so we have 3A cubed B minus A cubed B. Okay, so this gives us 2A cubed D. Then you have minus AB squared plus 2AB squared. That gives us plus AB squared. Okay, so yeah, a lot of things canceled out, and that was nice. So this numerator can be simplified further, so we can remove AB, factor out AB, and this will be 2A squared plus B all over 2A squared plus B. So this cancels this. So we'll have this is equals to AB at the end of the day. So we saw a lot of things canceled out, and we have a simple expression at the end of the day, which is AB. So let's look at, so AB is option E. So that's our answer. So we see that we started by the naive approach. So having this, but this was not in the options. So we had to, find something that was equivalent to it. Okay. And that's required us, finding C and D in terms of, AB. So I think finding C and D in terms of AB was very critical to this question. Okay. So that'll be all for this video. I hope you enjoyed the video. Please don't forget to share, like, comment, and subscribe. Comment so that the algorithm knows that we're doing something right. And see you in the next video. Goodbye, everyone.